Atomic structure for Cambridge IGCSE Chemistry. The IGCSE content includes a description of the atom in terms of the nuclear atomic model, the meaning and significance of isotopes, and how to calculate relative atomic mass. The nuclear atomic model has three types of subatomic particle: the proton, the neutron, and the electron. The mass, or most of the mass of the atom, is concentrated in the center in a small positively charged nucleus. The surrounding shells hold negatively charged electrons. Now, the particles in the nucleus are called the nucleons and have two types, as indicated by two colored subatomic particles here. Protons, which are positively charged with a relative mass of 1, and neutrons, which have no electrical charge but also have a relative mass of 1. The electrons, we know, are negatively charged. They have a relative mass of 1 over 1840, or 0.00054. Now, each atom has two numbers associated with it. So in this example, we'll have a 7 and a 3. The 7 is the count of nucleons. So we've got 1, 2, 3, 4, 5, 6, 7 particles in the nucleus. So the mass or nucleon number is 7. The second number is the atomic number, and that's just counting the blue particles, subatomic particles. That's the protons. So the atomic number is the proton number. So we've got two numbers, the nucleon number and the atomic number. Now, in an atom, the electron number equals the proton number. So if we look at this example, 1, 2, 3 electrons, 1, 2, 3 protons. That is true for all atoms. Thus, an atom has no overall electrical charge. The numbers of negative electrons is equal to the number of positive protons. So therefore, there is no overall electrical charge in an atom. Now, it may be useful to check that you have got all the facts of the nuclear model. Alternatively, you could skip ahead to the next slide. But I recommend you complete the table of properties for the three subatomic particles. So proton, we need the details of relative mass, charge, and position. What subatomic particle has no charge? What are the other details? And which subatomic particle is found in the surrounding shells, and what are the other properties? Okay, stop the lesson, complete those properties, and then come back to check your answers when you are ready. Okay, so let's have a look at what my answers are. Well, the proton has a relative mass of 1, a charge of 1 plus, and is found in the nucleus. The subatomic particle with no charge is the neutron, which also has a relative mass of 1 and is found in the nucleus. The subatomic particle found in surrounding shells is, of course, the electron, which has a mass of 1 over 1840 and a charge of 1 minus. So let's also have a go at interpreting mass number and atomic number. So we've got fluorine with the nucleon number of 19, mass number of 19, and an atomic number of 9. How many protons, electrons, and neutrons are there in a fluorine atom? Stop the class, come up with those numbers. Okay, so the numbers of protons is indicated by the atomic number, so that's 9. The numbers of electrons is equal to the numbers of protons, so that is 9. And the numbers of neutrons is the difference between the nucleon number and the atomic number. So 9 protons plus 10 neutrons makes a nucleon number of 19. Here's a second problem. Sodium, nucleon number 23, atomic number 11. How many protons, neutrons, and electrons? Stop the class, complete that exercise, come back when you are ready to check. Okay, so to restart, the numbers of protons is of course 11. The numbers of protons and electrons in an atom are the same. The numbers of neutrons is the difference between 11 and 23. So 11 protons plus 12 neutrons makes 23 nucleons. Let's now look at the concept of isotopes. Isotopes are atoms of the same element that have different mass or nucleon numbers. So another way of saying that is that they're atoms with the same number of protons but differing numbers of neutrons. So let's look at an example from the syllabus. Chlorine. Chlorine 35 and chlorine 37 are isotopes of chlorine. The numbers of protons are 17 in each case. The atomic number does not change. The numbers of electrons will be the same, 17 and 17, but the numbers of neutrons, 17 and 18 makes 35, 17 and 20 makes 37. The numbers of neutrons is different in each isotope. Okay, so here are two isotopes. The protons are the blue particle, neutrons are the green, and the electrons are red. How many protons, electrons, and neutrons in each? Can you identify the atoms, giving their mass number and their atomic number? Pause the class, come back when you have got your answers. Okay, so here are my answers. We've got 3 protons. On the left-hand side, that means we've got 3 electrons. Protons and electrons are the same, of course. And we've got 4 neutrons. On the right-hand isotope, we've got 3 protons again, of course, and 3 electrons again. They're the same for each isotope, but we've got 3 neutrons. So therefore, our symbols are 7 and 3, with the element being identified by its atomic number in the periodic table as lithium. And on the right-hand isotope, 6 and 3. So nucleon number 6 and atomic number 3. Nucleon number protons plus neutrons makes 6. Notice the isotopes have the same electron configuration. 2 in the first shell, 1 in the second shell. 2 in the first shell, 1 in the second shell. That means their chemical reactions are identical. So although they have different numbers of neutrons, they have identical electron configurations and therefore identical chemical reactions. So here is a different sort of problem. You've got the mass number for 2 isotopes and their atomic numbers. I decide on the numbers of protons, neutrons, and electrons in each isotope. Pause the class, come back when you are ready to check your answers. Okay, so here are the numbers of protons. Well, the atomic number is 10, so the proton number is 10 for each isotope. The numbers of neutrons is the difference between 10 and 20, and the difference between 10 and 22. So 10 neutrons and 12 neutrons. And then, of course, the numbers of electrons are the same as the numbers of protons. Here are some exam-style problems. You've got some information about various isotopes. Can you fill in the missing details? Pause the class, come back to check when you are ready. Okay, so let's look at the first one. Protons number is 6, which must mean we've got an atomic number of 6. The numbers of electrons is the same as the numbers of protons. 6 plus 6 makes 12. We were given the mass number, so we must have 6 neutrons because we got 6 protons. The second one is again carbon, so atomic number 6, 6 protons, 6 electrons, but we've got 8 neutrons, mass number of 14. Uranium 238, 92 protons, therefore 92 electrons, atomic number 92, 92 and 238, sorry, minus 92 is 146 neutrons. The last one, uranium isotope, well, we've got 92 electrons, which means we've got 92 protons, and therefore atomic number 92. 92 plus 143, or sorry, perhaps I'd indicate numbers of protons. 92 plus 143 neutrons makes the mass number or nucleon number of 235. What is relative atomic mass and how do we calculate it? The first idea to consider is that of percentage abundance. The relative amount of each isotope of an element is found to vary. Let's look at some examples. Chlorine, 3 of every 4 chlorine atoms has a mass of 35. The 4th has a mass of 37. So what would that be in percentage abundance? Well, chlorine 35, 3 out of 4, that of course is 75%. If you're not sure, 3 divided by 4 times 100. That leaves us with, of course, 1 over 4 times 100, or 25% for chlorine 37. Now, if we look at neon, 9 of 10 neon atoms have a mass number of 20, and the 10th has a mass number of 22. So we would say the percentage abundance, 90% neon 20 and 10% neon 22. So that's what's meant by percentage abundance, the relative amount of each isotope expressed as a percentage figure. So now the idea of relative atomic mass, which has got the symbol capital A subscript R. This is the number calculated for each element by averaging isotopic masses. So if we look at chlorine, we've just seen that chlorine 35 is 75% abundance and chlorine 37, 25% abundance. A true average must take into account this percentage abundance. The formula expressed in words is, of course, the relative atomic mass is the isotope of mass 1 times its percentage abundance plus the isotope mass of isotope 2 times its percentage abundance, all divided by 100. So if we apply this formula or this format to the chlorine data, isotope mass 1 is chlorine 35 and it's an abundance of 75. Chlorine 37 has an abundance of 25%. Divide by 100 comes to 35.5. And that is the figure you will see listed as relative atomic mass in the periodic table. So here is a problem for you to calculate. We've got the data on isotopic mass and abundance for neon. Can you calculate the relative atomic mass of neon? Stop the class, calculate, and come back to check. Okay, so mass of the first isotope 20, abundance 90, so 20 times 90 plus 22 times 10. Put that all into your calculator, divide by 100, Hopefully you've come out with 20.2. That is the relative atomic mass of neon, and you will see that listed once again in the periodic table. Okay, so firstly, well done for finishing. You need to do some practice. Find some questions in your textbook and then go on to past paper questions. If you're not aware of Maths and Physics Tutor website, that has unlimited numbers of questions and past papers. If you want some more related chemistry classes, look at the playlist or the links that are included in this video description. If you found this helpful, please recommend it to a friend. Subscribe for new classes and last-minute exam tips. Please like. Thank you very much.